Hello there. In this video we're going to discuss some basic transformations of functions, namely the horizontal and vertical transformations. So as a guiding example of a function, let us consider f of x is equal to x squared. I'm going to be looking at 3 points of reference, namely f of -1, f of 0, and f of 1. So notice that f of -1 is going to be -1 the quantity squared, which is 1. F of 0 is going to be 0 squared, and f of 1 is going to be 1 squared, which is going to be equal to 0 and 1. So we're going to see where these 3 points are going to be transformed to. So let us assume we have, as a first example, f1 of x is going to be equal to x minus 2 the quantity squared. I'm going to plug in some points, so namely f1 of -1, f1 of 0, and f1 of -1. So -1 minus 2 is -3 squared is going to be 9. 0 minus 2 is going to be -2 squared is going to be 4. And let's see, this should be positive 1. So 1 minus 2 is going to be -1 squared is going to be 1. So clearly these points, 1, 0, 1, are not mapped to the same exact points here, 9, 4, 1. So if we consider considering onwards, so f of 2 and f of 3, so 2 minus 2 squared is going to be equal to 0, and 3 minus 2 is 1 squared is going to be equal to 1. So notice that my points that I had originally are located here. So notice f of -1 has moved to f of 1, f of 0 has moved to f of 2, and f of positive 1 has moved to 3. So what can you tell me about all the x values? So notice that all the x values have shifted over to the right 2 units. And the y values are the same. So if that is the case, so if we look at our original function, so let us assume this is f of x, and we want to graph our new function, say f1 of x. So we're going to take all these points and move them to the right 2 units. So then we're going to have this function. So we have y is equal to f of x, and y is equal to f1 of x minus 2. So we see that this minus 2 shifts everything to the right 2 units. And in general, we have this is equal to x squared, and this is x minus 2, the quantity squared. Okay, great. So let's look at another example of this. So let's look at example 2. Let's look at, let's call it g. G of x is going to be equal to x plus 3 squared. So if we plug in some numbers, let's do like -4, -3, and -2 just for points. So -4 plus 3 is -1 squared is 1, -3 plus 3 is 0 squared is 0, -2 plus 3 is 1 squared is 1. So here are our 3 points that we were using as a comparison. So if we graph these points, so we have 1, 2, 3. So our vertex is located here, and all the points should be centered around it. So if we compare that to our original curve, so how do we get from green to blue? Well, we shift everything to the left 3 units. So that gives us this x plus 3 implies left 3 units. So let's just summarize this just to, keep us in the right direction. So we have y is equal to x squared, and we have considered 2 transformations, x minus 2 squared, and y is equal to x plus 3 squared. So we realize that x minus 2 squared implies right 2 units, and plus 3 implies left 2 units. And this is the original function that we're comparing it to. Alright, so let's consider another example. Let's see, f, g, let's call this new function h of x. let this be equal to x squared plus 3. So I'm going to plug in 3 points. I'm going to plug in h of -1, h of 0, and h of 1. So this is going to be equal to -1 squared. That's going to be 1 plus 3. 0 squared is going to be 0 plus 3. And 1 squared is going to be 1 plus 3. So that's going to be 4, 3, and 4. So notice that we have the original y values, and we add to it 3 units, and we get our new y values. So if we graph all those points and shift everything up 3 units, this is going to be the graph of h of x. So this plus 3 implies up 3 units. So if we have a look at a similar function, so example 4, suppose we have k of x is equal to x squared minus 7. We'll have a very similar scenario here. So h of -1, h of 0, and h of 1 is going to be equal to 1, 0, 1, minus 7, minus 7, minus 7. That's going to be minus 6, minus 7, minus 6. So we're taking all our original y values and subtracting 7 from them to get our new y values. So if we shift everything down 7, we'll get that this is the value of k. So this implies down 7. So we have some transformations that pretty much that we can summarize, right? So if we have our original function y is equal to x squared, and we can categorize this into 4 different components. So consider, y is equal to x plus 7 squared, y is equal to x squared plus 7, y is equal to x minus 3 squared, and y is equal to x squared minus 3. So let's, sort of review what we have sort of discussed. So this is going to be right 7. This is going to be up 7. This is going to be, actually this should be left. So left 7. This is right 3, and this is down 3. So the horizontal transformations, namely this one and this one, are sort of sometimes backwards from what you would intentionally think or initially think. So minus 3 is negative, so you would think that means to the left, but it actually means to the right, because the origin or the vertex of this parabola has shifted over to the right 3 units to make that equal to 0, because you need the opposite of negative 3 to make that 0, and you need the opposite of negative 7 to make this 0 as well. So the opposite of positive 7 would be negative 7, and the opposite of negative 3 would be positive 3. So left 3, right 3, up 3 is, or up 7 is going to be plus 7, and down 3 is going to be minus 3. So let's look at a few more examples of this. So let's look at, as an example, suppose we have f of x is equal to, let's see, x plus 3 squared minus 2. So if we compare these functions to 5x is equal to x squared, how would we transform that into this graph? So what does the plus 3 imply? So that's going to imply left 3 units, and this minus 2 is going to imply down 2 units. So if we were to graph the graph of f in this case, so we would go to the left 3 units, down 2 units, so that would be the location of the vertex. And then, so if this is minus 3 and this is positive or negative 2, so then we have this parabola here. And that would be the graph, or the sketch of f. And, as another example, if we have g of x is equal to x minus 2 squared plus 1, and we were to compare it to the same exact function, 5x is equal to x squared, how can we get from this curve to that one? So this x minus 2 is going to be to the right 2 units, and this plus 1 will imply that's up 1 unit. So if we look at our graph, so we're going to go to the right 2, and we're going to go up 1. So that would be the location of the vertex, and then all of the other points will be upwards. And that is some basic examples of horizontal and vertical transformations to basic functions.